Okay, so we're coming down to the end of the course here. So today you have 12.3 due, right? 12.2 and 12.3 due by midnight tonight. And then Tuesday you'll have the stuff from today's lecture due, okay? And then on Thursday you'll have the take-home exam and the one-way ANOVA that we'll go over on Tuesday, and then we'll do a final exam review and then final exam. Again, make sure that you are aware that the take-home chapter 12 take-home exam, okay, make sure you know that you need to download this, print it off, and then upload it as a PDF. Okay, now whether you want to scan that or take a picture of it and turn it into a PDF, or if you want to embed the images of the work that you did into a Word document, I'll accept Word as well, but you can convert Word to PDF real easy as well. So, so yeah, I won't take it as a Google Doc, and I won't take it as a JPEG image. So you do need to convert those files. Okay. And that's due in a week. So 1 week from today at 6 o'clock. Okay. Okay, and then again, that will be uploaded. So here, let me show you how you upload that. Go back home. Let me go to student view. Where's my student view? View as a student. Oh, here we go. Student view. Okay, so when I go to go on, keep going. When I go to this guy, it says take home exam. Okay, it'll say submit assignment. And if I click on submit assignment, it asks me, what do you want to do? Do you want to upload it as a file? You want to go to Dropbox, Google Drive, or Office 364? You're just going to upload it as a file. And then you'll choose your file, and then you'll upload, okay, your PDFs, okay, from your computer. Okay. Okay, and then you just click submit assignment. Okay, so this is due in 1 week. Make sure that it's not late. Again, it shouldn't be too hard to do. Most of everything is done on the calculator. So yeah. Okay, I'm gonna leave that.
Professor?
Yeah.
I don't know. Professor?
You have a question?
So when we turn in our take-home exam, do we need to like show the steps, the calculator steps?
Not the calculator steps, no. No.
Okay, so just the answer?
Yeah, exactly. Just the answers.
Okay.
Yeah, I'll just be grading whether or not the answer is correct. Okay, let's move into today's lesson. Okay, 12.4, 12.5, linear regression t-test. Okay. Use a t-test for the slope and correlation coefficient to determine if there is evidence that a linear relationship exists between two quantitative variables. Okay, must be quantitative. Okay, it must be numerical variables. Okay, number 2, check conditions for using linear regression. Okay. Use the regression line to make predictions given a proper conditions. Participants. There you go. Okay. We want to use a regression line to make predictions given the proper conditions. Okay. Why do a test on the slope? Why do, basically, we're doing a hypothesis test on the slope. Okay. Why do a hypothesis test on the slope? Because sometimes we just want to know whether or not there's a strong or weak correlation. Okay, is the correlation strong? Is the correlation weak? Okay, and we need a test on what is strong, what is weak. Is 0.6 strong or is 0.6 weak? You know, it may be closer to 1, but with regards to our data, we need a way to determine whether or not to say it's strong or it's weak. Okay, we need a value, and we need to reject that value or accept that value. So we look at the slope, okay, the slope here, and we say that the parameter version of our slope would be the Greek letter b or beta. Okay, so our parameters are usually the Greek letters like mu and sigma, and the parameter for slope of our regression line is beta, okay, or a Greek b. So we'll write our hypothesis using this symbol. Also recall a slope of 0 means that there is no association between the two variables. So beta equals 0 represents the assumption that no association exists, and that we are looking to show that an association exists. Okay, a slope, whether positive or negative, actually exists. Okay. Okay, what are the conditions for our assumptions? Okay. Linear, the relationship appears to be linear. So if we have, you know, a bunch of data, okay, we want to make sure that that data appears to be linear. Okay, linear data. Okay, so we want no curves. Okay, independent, the residuals are assumed to be independent, not based on time or some other factor. So we want no relationship between the observations. We don't want them to be dependent. Okay, we don't want list 1 and list 2 to be dependent on each other, you know, or paired data. So no paired data. Okay, no before after data, like, oh, you know, this person did before and then this person did after. No, we want 2 completely different data sets. Okay, normal distribution for the residuals, we want it to be unimodal. So remember, the residuals were the differences between the line and the residuals are the differences between the line and the observed, the difference between the expected and the observed. Well, if I calculated all those residuals out, okay, I should get a normal distribution, okay, unimodal and symmetric. Okay. Okay, equal variances in the residuals. So again, if I calculate out the residuals, okay, this chart is based on 3 data sets. Okay, but if I calculate out the residual values here, okay, I would want them to vary about the same. Okay, vary about the same. Okay, what we call that when we have equal variances, okay, we call that homoscedasticity. Okay, same variances. Okay, we want no funnels. No funnels. What's a funnel look like? We don't want anything that looks like this, okay, in our data set. If we have in our original data set, okay, go something like this, that's bad. Okay, no funnels. Okay, and we want the data to be random. Okay, data produced are from random sample and or a randomized experiment. Okay, so let's do an example of this. Okay, it says on StatCrunch from previous Math 219, final exam is shared. Okay, and there's the bit.ly right there. Okay, bit.ly final exam data. Okay, so I'm going to go to StatCrunch and plug this in because it's a lot of data, and I don't really want to plug this into my calculator by hand. Okay, so I'm just going to use StatCrunch. I'll show you how to do this on the calculator as well. But if I pull up this data set, okay, from StatCrunch, I have to log into StatCrunch first. Okay, and then I'm going to put in that URL. Okay, and it is okay, bit.ly, okay, and / final exam data. You should be able to do this as well. Okay, final exam data, and I'm going to push enter. Okay. Data. Okay. Oops, I screwed up. Should be exam data, not a SAM data. Exam data, there we go, let's try that. There we go, boom. Comes up with the StatCrunch, with the data that I want. Boom, like I said, it's a lot of data. Okay, so there's like, we'll run for, I don't know, 60. There's 60 pieces of data. So again, that's a lot to put in your calculator. Okay, so I want to know, is there a relationship between the multiple choice and the free response? Okay, was there a relationship between the multiple choice questions, the percentage on the multiple choice, and the percentage that the person got on the free response? Okay, so, and we're not really pairing this data together. We're just running it as an aggregate. Okay, multiple choicers versus free responders. Okay, so let's set this up. Okay. So what's the hypothesis going to be? Okay, we want to know if there's a strong evidence. If you did well on the multiple choice, then you did well on the free response. Okay, is there a correlation there? Well, if I were to look at, say, multiple choice versus free response, okay, so we would think that there would be a strong linear trend upward, a strong positive trend. So my hypothesis, my null, is going to be that beta, or the slope, is equal to 0, that there is no correlation between the two. And I want to know, can I reject that and accept the fact that there is actually a positive correlation? Okay, a strong positive correlation. Is it strong enough for me, okay, to have a positive correlation there? Okay, so what's the name of the test? The name of the test is the linear regression t-test. Okay, linear regression t-test. Okay, and you could put in here for slope if you want. Okay, for slope. Okay, the conditions. Okay, is the data linear? Well, we'll see. Okay, we'll just say no curves on scatter plot, no curves. Okay, and again, you would do this if you plotted this data. You should be able to see. So let's do that real quick. Let's plot this data. I want it to be plotted. Okay, so how do I do that here? Stats. Oh, graph. Here we go. Graph. Graph. I want a scatter plot. Is what I want. Okay. What's my x variable? My multiple choice. What's my y variable? Is free response. And then compute the scatter plot. Geesh, that is all over the place. Okay, look at that. That's. Is there a linear trend there? It's really hard to see. There's a lot of like, some people did really well in the multiple choice and really bad on the free response. Some people did really good on the multiple choice and really, bad on the multiple choice and really good. There seems to be a linear trend, positive, but it's kind of hard to see. Okay, it's kind of hard to see there. Okay. If we did a linear regression on this as well, okay, but again, let's go back to this. Let's go back to this guy. We'll do linear regression a little bit. Go back, results. Show all. Okay, here we go. So here's our scatter plot, and what are we looking for? We're looking for, are there any curves on the scatter plot? No, it looks like kind of just a mess. Okay, any curves on this scatter plot? Okay, is it linear? Sure, we'll assume it's linear. Go back to the plot. It's not one. Okay, no curves. Independent, we're going to say that that is assumed that it's independent. Okay. Normal distribution of residuals. Okay. We're not going to calculate the residuals. We're just going to assume that that's true as well. We're just going to say it's unimodal and symmetric. Okay, and equal variances. Are there any funnels? Okay, we're going to say no funnels on this. Okay, and random, is it random? Yeah, this is random data. Okay, so we want to do our calculations on this. Okay, so let's do our calculations. Okay, so let's go back here to the data. Okay, the data set. Okay, so now I'm going to close this out real quick. Now we want to run this with a simple linear, okay, regression. So we're going to go to stat, okay, stat and regression and simple linear. Okay, what's the x variable? It's multiple choice. What's the y variable? Free response. Okay. Okay, and then it says perform a hypothesis test, simple linear regression. That's checked. And then the slope here, okay, what do we want here? The slope, we want to be greater than 0. Because that was our hypothesis, was that the slope is greater than 0. It's a positive slope. That's what we want to test against. Okay, so just change your slope there to greater than. Okay, everything else is fine. Okay, and then I compute. Okay, And I'm really looking, okay, let me open this up here. Okay, I'm really looking at the slope. I don't really care about the intercept. Okay, the slope they calculated, okay, again, for the free response equals, so let me write this down real quick. Okay, so the free response is equal to 7.03 plus 1.01 times the multiple choice. So that's my regression equation. Okay, and so what was my regression equation? Was that y, which we're calling the free response, okay, or y hat, is equal to, okay, the intercept, which was 7.03? Yeah, 7.03 plus the slope, which is 1.01. It's almost like how you have a one-to-one correlation there, which is kind of nice. Slope is 1.01. Okay, for every point that I got right in the multiple choice is a point that I would get right on the free response. So that's kind of cool. Okay, so we took that kind of shotgun blast data there and we actually created a nice linear regression. Okay, free response is equal to, and that's times x. Okay, so this would be, this is, again, the free response is the y hat, the x is the multiple choice. Okay, that's the multiple choice, is the x value there. Okay, so that's my linear regression, that's my line of best fit. Okay, now in doing this, okay, that also gives me the parameter estimates, okay, and under the parameter estimates, I have the slope here, okay, and it says what's the t-stat here. So it does the hypothesis test, okay, for greater than, for the t-stat, and that ends up being 6.67, okay, roughly 6.665, okay, and the p-value is nearly zero. This just means it's pretty close to zero. Okay, so the calculation, okay, the t score, okay, the t score is going to be 6.665, and the p-value is going to be equal to 0, which is less than my significance level. My significance level was 0.01. Okay, which is less than 0.01. So what's my conclusion? The conclusion, okay, is that we reject HO, okay, which was what? What was HO? It was that the slope is equal to 0. So we reject that. The slope was not equal to 0. Okay, the correlation between the two was not 0. Okay, think of beta as the correlation, not necessarily the slope. Okay, but there is a slope. Okay, and we can reject that because it's less than our significance level. Okay, there is sufficient evidence to suggest a positive correlation between the multiple choice and free response scores. Okay. Okay, so now let me show you how we would do this on the calculator. Okay, and for that, I actually want to go back to what we were working on before. Sorry, does anybody still need that? Kind of. Okay, let me know. We'll come back to this because I have to cover 12.5. This little line there as well, but okay. I would like to go back to the baseball one that we did before. Maybe we'll do that one. What would be a good example here? Or the McDonald's sandwich one. Okay, the screwdriver one was okay. Okay, let's see. I just want to grab some data for. Okay, that one's going to be a little bit much to put that in. It was good data though. Let's do the screwdriver one because it's less data. I don't want to spend a lot of time plugging data into the calculator. Let's see here.
Professor, the audio is getting really staticky.
Oh, it is. Okay. Let me stop my share real quick. Let me exit out of this stuff. Okay, and then cancel. Okay, let me try sharing again. Good. Okay, testing 1, 2, testing.
That's clear.
Okay. Okay, let me go back to sharing my screen real quick. Okay, so let's go back to the scuba diver one there, and I'll show you how to run the test on this one. What the heck? Okay, so let me put in the data real quick. Okay, I think we even ran this last time on, and we had a graph. Remember this graph here on the data, right? So, so if I plug in the data, let's go to stat. The data should still be in there. Oh, lovely, it is. Okay, so if you plug in your data here, it's 50, 60, 70, 80, 90, 100, 80, 55, 45, 35, 25, 20. And I'm gonna run a linear regression t-test, right? A linear regression t-test on this data. So I'm just gonna go to stat, tests, and I'm gonna arrow all the way down until it says linear regression t-test. Where's the linear regression t-test? Linear regression t-test. Looking for linear regression. There it is, right there. F. F is linear regression t-test. Okay, and then it's going to ask me, what do you want as your X? List 1? Yes. Okay, what do you want as your Y? List 2? Yes. Okay, do you want this to be not equal to, less than 0, or greater than 0? What do you want your beta to be? And I want it to be greater than 0. I want it to see if there's a positive correlation. That's what my guess is. I'm guessing that there's a positive correlation. And so then I calculate this, okay? Actually, I should be guessing that there's a negative correlation. I'm sorry. We want to guess that there's a negative correlation, right? Because as I go up in depth, I go down in time. So that would be a negative correlation. I want to calculate, is there a negative correlation here? Okay, if I calculate the positive one, I probably would get an incorrect conclusion. Let's enter this, and let's see what we get. We get a t-score of a negative 7.14, and I get a p-value of 0.001. It also calculates my A and my B here. My B is my slope, okay, negative 1.11, and my A is 127.23. So, so you can see that I would reject that it's equal, and I would accept that it's less than 0, and that's exactly what we're seeing here. Right, so HO would be that beta is equal to 0. HA would be that this is going downhill. It's a downhill trend. HA would be that beta is less than 0. And so since P is so low, I would reject the null and I would accept the alternative, that there is a positive relationship here. I'm sorry, a negative relationship here. okay, on this one. That's how you would use a calculator for that. Okay, again, most of the time you won't use the calculator, and I'm not going to have you run any of these. If I do put one of these on the final exam, you'll have the data in front of you. You won't have to do this by hand. Okay. Okay, so let's go back. Exit out of the calculator real quick. Okay, let's go back to 12.4 and 12.5. Let's talk about this very last line. Okay, 12.5. Okay, it says, what should I use to estimate my y variable? Okay, my y variable, where you're going to use your regression line. Okay, so if we get a regression equation, okay, like before, we got this y hat is equal to 7.03 plus 1.01 times x, right? Or I'm gonna put in the labels here. The free response was equal to 7.03 times 1.01 times the multiple choice. Okay, and what should I estimate for my y? How could I estimate my y value? Well, it says use the regression line to estimate. Okay, if your p-value is less than alpha, if there is a positive, if there's a positive correlation or a negative correlation, okay, if I reject my null, then I can use the regression line. If I don't reject the null, I can't use the regression line because the regression line is totally useless. Okay. To get the y value, in that case, I would use the mean, the sample mean of the y values. Okay, y bar. Okay, so if we accept HA, okay, our alternative hypothesis, accept HA, then we use the regression line. Okay, if we reject, or sorry, if we accept the null, if we accept HO, then we just add up all of our y values and we find the mean of all of our y values and we use that as our best estimate. Okay, of what y should be. Okay, that just means that there's no, okay, we take the average. So again, if we go back to, okay, if we go back to our data, kind of, I think I exited out of our data. That's okay, I'll get it back. If we go back to our data, okay, so it's saying the x values are the multiple choice, right? So say that we rejected, or we failed to reject the null, that the data, well, how would I find what the y value, what the predicted y value would be given any x value? Well, that just means that it has a slope of 0, which means it's a horizontal line. So I would just average up these values. So how would I average up these values? Well, I would just go to my data, okay, and I would no, I would go to my calculator, okay, and do summary stats on my column, okay. So summary stats on my column, and what do I want? I would want for my free response, okay, I would want the mean for the free response, because those are my y values. And then I would compute that, and the mean there is 70.38. That's the average Okay, that's the Y bar. Okay, so I'll go back, and so Y bar for this guy, okay, is 70.3. Was it 70.3 or 70.4? 70.4. Okay, 70.4. So it's just saying, you know, we would run with that number if we rejected, if we fail to reject the null, if we accept the null. Okay, that beta is equal to 0. Again, beta equaling 0 means that there's no correlation and the regression line slope was 0, which means that for any x value, the regression line is going to have a mean of the average of the y values. Okay, it's just going to be the mean of the y values. Okay, so that's what we use for our best attempt at how to estimate my y variable. So again, if we get beta to not be equal to 0, then we just go with the regression equation. Okay, so that's how we get y. Okay, and that'll do it for us. It's a pretty simple, a pretty quick lecture today. Okay, so once again, you're free to hang around and finish up your homework. Let me know if you have any questions on that. Okay, or anything else up to this point. Okay, we'll have one more lecture that will be on Tuesday. Thursday of next week, you'll be turning in your take-home exam, and then I'll be fielding any questions that day. That day will only be an hour. Class will only be an hour next Thursday. Exam review the Tuesday after that, and then the final exam will be the Thursday in 2 weeks from today. Okay, so again, coming down to the last 2 weeks. So, yeah.
What are we covering on Thursday when we turn in the exam?
Nothing. We're
Oh.
not covering anything. You'll just be turning in the exam and the chapter 12 exam, and I'll just be fielding questions. There's no lecture next Thursday.
Oh, okay. Okay, thank you.
Okay. Okay.